Assalamualaikum and good morning. We are from Group 6 from DKM5A. I am Muhammad Afiq bin Muhammad Nazri, 01 DKM5A. Our title for case study part 1 is Basic Component of Gas Turbine Power Plant. This is our group members, which is Aidil Ashraf, Muhammad Arif Hakimi, Mas Farish Khirwizam, Muhammad Ikmal Adli and me, Muhammad Afiq. So, first of all, we go to introduction to basic component of gas turbine power plant. The gas turbine is the engine at the heart of the power plant that produces electric current. A gas turbine is a combustion engine that can convert natural gas or other liquid fuels to mechanical energy. This energy then drives a generator that produces electric energy. There are three basic components of gas turbine power plant to make it working perfect, which is compressor, combustion chamber and turbine. This is basic component of gas turbine power plant. The next slide of presentation will continue by Aidil Ashraf.
Thank you, Afiq. Right now we go to working principle of basic component of gas turbine power plant. So basically, the fundamental of principle of gas turbine power plant is still the same with steam turbine power plant. The only difference is there is steam turbine power plant we use a compressed steam to rotate the turbine, but in gas turbine power plant we use compressor air to turn the turbine. Now we go through the working principle of basic component. First, in the gas turbine power plant, air is compressed in a compressor. This compressor air then compressed through a combustion chamber where the temperature of the compressed air is rises. That high temperature and high pressure air is passed through a gas turbine. In turbine, the compressed air is suddenly expanded and gain kinetic energy, and because of this kinetic energy, the air can do a mechanical work for rotating the turbine. So in the gas turbine power plant, the shaft of turbine alternator air compressor are common. The mechanical energy created in the turbine is partially utilized to compress the air. Gas turbine power plants are mainly used as standby auxiliary power supplier in hydroelectric power plant. It generates auxiliary power during starting of a hydroelectric power plant.
Assalamualaikum warahmatullahi wabarakatuh. This is my part number 1, is compressor. Okay. From the diagram, as we can see, it starts from starter. It has a starter. Then we start the compressor. Then the airflow will go into the combustion chamber, and then to turbine. Then compressor and turbine is combined by the shaft in the middle. Compressor supplies high pressure air for combustion process. And use compressor type. Type suitable use is radial or centrifugal flow compressor. Number 2 is axial flow compressor. 2 is combustion chamber. As we can see in the diagram, combustion chamber is located at the middle. So where air full and air mix, the gas turbine compress air and mix it with fuel, that is then burn at an extremely high temperatures, creating a hot gas. Then hot gas spins turbine blades. The hot air and fuel mixture move through blades in the turbine, causing them to spin quickly. Okay, the last part is turbine, the last part of process. Okay, spinning blades turn the drive shaft. This fast spinning turbine blades rotates the turbine drive shaft. Turbine rotation powers the generator. The spinning turbine is connected to the rod in a generator that turns a large magnet surrounded by coils of copper wire. Okay, number 3 is generator magnet causes electron to move and create electricity. The fast revolving generator magnet creates a powerful magnetic field that lines up the electrons around the copper coils and causes them to move. The movement of these electrons through a wire is electricity.
Okay, Assalamualaikum. My name is Maswari Khirwizam Masyamanasing. My number is 01 DKM5A 1026. I will explain about the diagram of basic component of gas turbine power plant. Okay, as you can see, this is a brightened circle. The 1 and 2 is a compression, 2 and 3 is a combustion, S3 and 4 is expansion through turbine and exhaust nozzle, and last one is atmospheric pressure. Gas turbine unit are open cycle basis with a rotary compressor and a turbine mounted on the common shaft. In addition, additional equipment can be added to the simple cycle gas turbine, leading to increase the efficiency and or the output of unit. Okay, next. As you can see, this is an open gas turbine engine. Firstly, the fresh air will enter to the compressor, and compressor will compress the air and go to the combustion chamber, move with a fuel, and then the combustion chamber will do its work and go to the turbine. And last one is go to the exhaust gas at number 4. And last one is a basic component of gas turbine power plant. We have a starter, compressor, combustion chamber, turbine. Thank you for me.
My name is Muhammad Iqmal Adli bin Akmal. My method number is 01DKM18F1027. Okay, now I want to talk about summary and conclusion of basic component of gas turbine power plant. Advantages of gas turbine power plant. It is smaller in size and weight as compared to an equivalent steam power plant. The initial cost and operating cost of the plant is lower than an equivalent steam power plant. The plant requires less water as compared to a condensing steam power plant. The plant can be started quickly and can be put on load in a very short time. The maintenance of the plant is easier and maintenance cost is low. The lubrication of the plant is easy. In this plant, lubrication is needed mainly in compressor, turbine main bearing, and bearings of auxiliary equipment. And lastly is the plant does not require heavy foundations and building. Disadvantage of gas turbine power plant. First major part of the work developed in the turbine is used to drive the compressor. Therefore, network output of the plant is low. Next, since the temperature of the product of combustion becomes too high, so service conditions become complicated even at moderate pressures. Conclusions. In conclusion, the gas turbine represents a cost-effective resource for the balance of plant in the fuel cell system because of its energy conversion performance and the availability as off-the-shelf equipment.